This video is hopefully the last one you need to watch about bit depth to understand it properly. And I'm going to talk about 8 versus 10-bit, but bit depth in general. But we need to start by understanding what the hell is a bit. And if we get that, then the whole thing will be a lot easier. And you have to think about it kind of like this, right? We've got our sunshine, and we've got our camera, and we've got our computer over here. And in order for us to get an image onto our computer, we have to process an image here in a camera, digital camera, and that image has to tell us the values of brightness and darkness. Is it really bright? Is it really dark? Bits allow us to do that, and bits is just a number. That's all it is. And think of it like a code, right? And a bit has two options. We can say this one bit, so this box, we can say it's a yes/no question. Is this box black? If it is black, we're going to give it 0. Or is it white? We'll give it a 1. That's our only option with one bit. We can give it a 1 or a 0 because it's a single thing we're talking about. One bit is binary. That is the basis of every decision, everything out there with computers. Now, computers have developed into a lot more information. And that's really important for us because if our camera was one bit, it would mean every pixel on your camera could either say it's completely white, it's completely black. There'd be no other options. And you'd get not a black and white image in the way you'd expect. It'd be very patchy. It might be your entire top half, the sky, is just white, and your entire bottom half of the ground is just black. Now, 2 bits, we are doubling the number of options we have, right? So we're saying, okay, well, we've got 2 options there, 1 or 0, and we've got 2 options there, 1 or 0. Now this gives us 4 new options. We can have 1 and 1, 1 and 0, 0 and 1, or 0, 0. It's about how we start to put these numbers together because we're saying, consider all of that, and we now have these options. So with 2 bits, we can go, okay, we've got 1 and 1, 1 and 0, 0, 1, 0, 0. And we can turn each of these into a color, a luminance value. So we can now say, okay, this is the brightest, this is fully white, and this is the darkest, this is fully dark. But we also have, maybe this is like dark gray, and maybe this one is light gray. So now we have 4 shades if we were working in 2-bit. So you see we've gone from 1-bit to 2-bit, we have doubled the number of options we have, the number of shades we have. And what this looks like in a pixel is, imagine this is 1 pixel and it's a bucket, right? It's a 3D pixel. So, we're looking at it like from the side. If the bucket is full, this is white. If the bucket is empty, this is dark. And the reason we use this bucket analogy is we're talking about the amount of light coming in, this sunshine coming in. And if it was, let's say this amount of light came in, half our bucket, if we were working in 1-bit, then we have to decide, well, is it white or is it black? We don't have any other options. We can only give this a 1 or a 0, and 1 means it's full and 0 means it's empty, which is not very helpful. Then we go to 2 bits, we could say, okay, well, which region is it in? Is it black, dark gray, light gray, white? And maybe if it's in the middle, okay, we have to pick and choose. Is it light gray or dark gray? That's not ideal, right? There's so many shades out there, but it's better than 1-bit. I hope you're with me so far, because what happens is just going to extend the same idea just a little bit further. So 1-bit, so 1-bit, we had, what did I say? We had 2 options. 2-bit, we had 4 options. 3 bits, we have 8 options. We're doubling again. So let me show you why. If I was to add another option, so another number, we can now have 111, 101, 011, 0, 0, 0. So there's 4 options. Oops, shouldn't have done that like that. Or if this is a 0, we could have 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0. We've got 8 options now just by adding 1 extra column. That's what we're doing here. So we're talking right now in kind of low bits numbers, but we need to think a little bit more advanced than that. So if we just do the math really quickly, 1 equals 2, 1 bit equals 2 options, 2 bit equals 4, 3 equals 8, 4 equals 16, 5 equals 32, 6 equals 64, 7 equals 128, 8 equals 256, right? 8 bits. We have 256 shades we can work with. But we aren't stopping at 8-bit, we're going to 10. So double of 8 is 512. And double that, 10-bit, is 1024 shades. Now, why this is important to kind of grasp is when we're thinking about how that looks in terms of the detail that we're getting back. And this is where in color grading, you'll notice sometimes where you get like a blocking banding in the sky. It seems like those shades are really separated. They're not a nice smooth gradient. If I'm to draw a pixel over here, same thing, right? Looking from the side, and this is 8-bit. I now have within there, I've got 256 categories of shade, right? That's way more than I can fit in there. So however much light comes in, that light comes in to here, I can give it a number. If it's right in the middle, it's gonna be, okay, if that number's right in the middle, it's 128, or maybe it's a little bit brighter. So we give it 129, right? That is 8-bit. Now, because we're doubling it though, every bit, and we're going up by 2, this is that same amount of information, same pixel size, right? Pixel is a pixel, but 8-bit into 10-bit, we now have, if we've got 1024 shades, that's what we're saying, 1024, half of that would be 500 and, oh God, I shouldn't have put the 0 there, sorry, 512. And half of that is 256. So can you see 8 bits is only a quarter amount of the possible shades of 10-bit. Now maybe you're looking at this and going, okay, so why is it 8 and 10? Why not 9? Why not 7? Why not these other numbers? Because of the way computing is done, well, there's more than I know really, it works in even numbers. So theoretically, you could have 9 bits or 7 bits or 5 bits, but because computers and processes have been designed to work on these even numbers, it's just easier for them to be done this way. So you do now get 12-bit and 14-bit and 16-bit, but these are the common two, 8-bit and 10-bit. When we're talking about just shade right now, just luminance, black and white, grays, this is the benefit. We're going to have a lot smoother when we've suddenly got 4 times the amount of numbers we can give different shades, right? Different levels of black to white. But this is where things get a little more confusing, but hopefully not too much more confusing. You might hear people say like, well, that 10-bit is like 1 billion colors versus 16 million colors or whatever. I'm going to explain to you why, and it can be a little confusing to understand, but try and stick with me. So your sensor, if I do this right, probably won't do. Your sensor is made up of a certain pattern, and that pattern is every square, every 4 pixels, 2 of them are going to be green. And the reason this is, I'm going to have another video about this in a bit more detail, but basically your eye, it can see green a lot better than the other colors, so we prioritize it. So you can see that wherever I pull out 4, let's say pull 4 here, I'm always getting red, green, and blue. Now the fact there's 2 green doesn't impact what I'm about to say because they're still the same color. So every pixel on your camera, it's not that the pixel itself is green or blue or red. Every single pixel is the same. However, they have either a green filter on top or blue filter or red filter. All right, if I just do another one over here. And what happens is, if I just pull out 3 to the side, I'll get rid of this and then I can draw it a bit clearer for you. So if I have 4 pixels and I'm saying 2 are green and 1's red and 1's blue. Now, this applies here, right? Every pixel here, let's say we're working in 10-bit, we've got potentially 1024 shades, but the only light that can get in through is green light. Blue and red light doesn't come in, it gets bounced off. And the same thing happens, except with the different colors over here. So the only one that gets through is the red light, and the only one that gets through here is the blue light. What I now have is 1024 shades of green. I've got 1024 shades of red, and I've got 1024 shades of blue over here. And yeah, I've got 1024 shades of green, but they're the same. Even if they have different numbers, they're still shades of green, right? That's not changing. But what you need to grasp is this. If I'm filming the sun is yellow. It is not blue, red, or green. So we need to tell our camera, well, what shade is that sun? And the way it does it is it's going to figure out by combining green, red, and blue and figuring out, well, what is that shade? Yellow is made from red and blue, I believe, in terms of this video language. So let's say the red was 80% and the blue was 80% filled. So they're up at 800. That's the value they've been given. Been given a value of 800 and a value of 800. The green is really low. Let's say it's 10 and 5. Let's make them different just to prove my point here. To get yellow, what your camera is going to do is it's going to take these numbers and figure out, well, what's the middle, what's the average, and that will be yellow. And so when people are talking about how many shades does bit have, we're saying green times red times blue. And we're forgetting that fourth one in the situation, because this is part of the Bayer pattern, which that video will be the next one I post, so you don't get confused. But now we've got 1024 shades of green times 1024 shades of blue times 1024 shades of red, or red blue. Now I've got that many colors to work with, and that number is, yeah, compare that to 8-bit, which is, that is bit depth. It's about shades and how that turns into color because of this pixel filter system. I hope that's helped. I hope that hasn't made you more confused. But what you've got to also just remember is that by going from 256 to 1024, we're quadrupling the amount of information, because we are still having to store those digits, those numbers, which means that your card space, your computing process is a lot more intensive. So 8-bit, you will get way more space on your card than with 10-bit. But if you know you're doing lots of color grading and you want a nice image, 10-bit is a better choice.